Okay, so continuing on to the last part of our topic three. So this is hopefully you guys are all ready. So this is regarding we are still regarding the thermal heat and thermal insulation of a building. So humidity in the air is actually a problem. So when it comes to a building, so when we have a building, usually that building is an enclosed area. So if we have insufficient window or we have insufficient opening, then we can have very, very high humidity in a building. So what happens when we have a very, very high humidity? Then condensation can happen. So what is condensation? Condensation is when water vapor touches a surface of a material, doesn't matter if it's a wall, your plaster, or even the glass window. Usually that will be more prominent lah. If you touch your glass window, then you'll be able to see water droplet being formed on your surface. So this is what it means by condensation. So this happens when the humidity reach a high enough level or when they reach the dew level. So that will we will go more into it later on. Okay, so when it happens, then we can have all sort of unwanted stuff lah going in our house. So this is an extreme example. If you have a wood, then we can have mushroom. And then besides that, the very dangerous part is we can have black fungus or mold. We can have mold in it. And then this can cause peeling of the wallpaper if you have a wallpaper in a building. But generally, it can cause growth of fungus or mold, lah, which is doesn't look very good and is also and this is also actually very unhealthy. So this is also very damaging lah to our health in terms of it can cause allergy, it can cause asthma attack. So having a very high humidity building or building that is not well ventilated, which can accumulate humidity, can cause a lot of problem in terms of bad air in the room and then cause condensation in the building and cause growth of all these fungus that we do not want. So it also cause damages to structure lah. So when it comes to people, general concern is health concern, damages to material, peeling of the material like this. And then if you have wood in Malaysia, generally you don't see a lot of wood, then the wood will start to rot lah. Okay, so the principle behind condensation is it will happen when warm moist air meet a surface that are below dew point of that air. Meaning we have a warm air and they touch a so cold surface here. For example, here, if you look at it here, you have a warm air, 21 degrees, and they touch a cold surface, and then the point at which the temperature at which water starts to form is at 10 degree. So when this and this, when they equalize, and if this warm air, the temperature reaches 10 degrees Celsius, then condensation will start to happen. So this is what it means by condensation in building occurring whenever warm air meets surface that are or at below the dew point of that air. So when this warm air touches a cold surface and this air, which has a RH, which is a relative humidity of 50%, when they touch together and this temperature is at a lower value than this dew point, meaning an equation, you add them together, and they are lower than this value, then water will start to form on the surface of this cold surface. Like what we have with the cold glass, then we see a lot of condensation happening in our glass. So a general requirement for all of this condensation to happen is moist air. Like in Malaysia, we are in a tropical country, so our humidity is actually very very high, and then we have cold surface. So this is the condition in which how a condensation happen. Okay, so we have actually four factors that influence condensation. So the first is the moisture source. So any moisture present in the sample of air comes from a water source. So in our air, we have humidity, which is water content in the air. So this water content in our air can be controlled. So if we are well ventilating our room, then that means we are ensuring that moisture is not being contained or accumulated in the room. So to prevent that, we want to eliminate any source of water that can add to this moisture content in our room. So you want to remove any water source. So usually this moisture comes from our occupant and any activity that we are doing. So if we shower, once we finish showering, then you'll notice that our mirror starts to fog up. So this is usually when we shower a hot shower meaning you use hot water. So we have a very very hot moisture being evaporated in the shower room. And then when it comes into contact with the cold surface of the mirror, then you'll notice that when we are in the shower, whenever we finish showering, if we took a very, very long shower, then we will see that the mirror in our shower room will get fogged up. And then when we open our door, after a few, like maybe 5 minutes later, then you'll notice that everything is clear. So because this is all due to the changes in moisture content in our room. Okay, so next off we have temperature. So when it comes to difference in temperature, meaning difference in the heat in the area, so warm air can actually hold a lot of moisture as compared to cold air. So in the same room, if the temperature of the air is higher, they can actually hold more moisture as compared to a cool air. So a cool air, meaning a cold air, they are less likely to cause condensation and they will have a lower moisture content. And then if you have very, very high ventilation, then we're actually removing the moisture content of the building to reduce the risk of condensation. And then depending on our use of building, either we are heating it up or we are having any moisture making activity, then there will be a higher chance of condensation happening. So in the case of like a shower room, you see that our mirror will always fog up because there's changes in the temperature and then there's very little ventilation. So that happens a lot of time. Okay, so to prevent all this condensation, you want to have ventilation. So this way, you'll be able to remove the moist air before any condensation can happen in the surface. Besides that, there's two more alternative, which is heating. So when we heat the temperature of the air, they can actually hold more moisture. But this costs money and you need to have appliances to do that. So what this does is that this keeps the humidity in the air above the dew point. So if all the surface in your building or in the room is heated up to to the same level as the air in the room, then condensation cannot happen because the dew point is too low. Okay, then finally we have insulation. So this is just to reduce the rate at which heat is lost through a structure, keeping the inside surface warm. So the idea here is if our surface is warm and if there's not a very big difference between our air temperature and surface temperature, then condensation does not really happen. Okay, let me do a quick check again. Here. Okay. Okay, so to check humidity, then we have a few appliances. So we can have a hair hydrometer, and then we can have a wet bulb and a dry bulb, and then we can have an electronic hydrometer. So this is able to detect how humid is for in the air, the humidity of the air. So this is the latest digital appliances that we have. Older days they use this. So next off we have this. So this is basically a thermometer. So what it means by wet bulb and dry bulb is here the surface is just exposed. So this is called a dry bulb. But when it comes to a wet bulb, the material we have a tip here. Usually it's metal. You can have it covered with with a material, with a cotton material. So this is what it's called by a wet bulb. Okay, so here, when we're talking about humidity, so in our air contains a standard level of humidity. So in the case of Malaysia, you'll notice the difference when we have a high humidity and a low humidity. How it affects us is that we can actually feel that when the humidity in the air is higher, then we'll actually feel uh, the temperature will be even hotter. So then, if you were to be in that sort of situation, we'll start to sweat. So when we start to sweat, if the humidity of that area is very high, you'll find that this sweat that we generated will be very hard to be evaporated off from our body. Then this causes us to feel even hotter. So this is how humidity can affect us. So having a very high humidity in an area is not very good. And then we have water vapor. So humidity and water vapor is the same thing lah. So water vapor is just a gaseous state of water. So this one is all a repeat lah. A repeat of warm air can hold more moisture than a cold air. Okay, so moisture content can be equated in a formula such as this. So you can have a mass of water vapor in an air sample and then mass of that air sample when dry. So moisture content is in terms in percentage. So they are in a percentage where this mass of air sample when it's at the driest 0%, and then mass of the same air sample at how much water content is in this air sample. So this is what it means by moisture content. So that's why they are in a percentage and their unit is something like this, either kg per kg or gram per kg. So usually you don't have this. So you work it out in kg per kg, so it will be in percentage. Okay, so next, as mentioned, the dew point is a fixed sample of air, is a temperature at which a fixed sample of air becomes saturated. So it means water starts to form lah, on a surface. And then next we have relative humidity. So this is a measure of amount of water air can hold at a certain temperature relative to the amount of water that air at the same temperature can hold at 100%. So RH is how much water this air can hold. So if we are at 100%, then it's fully saturated. No more water can be in the air. So when it's at 100%, then you have a lot of water lah in the air. If it's at zero, then it's a very dry, perfectly dry air. So what we can do is to increase or decrease the amount of water that can be held in the air. Essentially, we can heat or cool them down to increase or decrease the amount of humidity. So example 9 just showcase a simple example of using all these formula. So we can have a sample air of relative humidity of 40 degrees, and then the given temperature is 20 degrees. So here is asking to calculate what is the vapor pressure of the air. So you give in the SVP, the saturated uh, vapor pressure of water is 2340 Pascal at 20 degrees Celsius. So to work this out, you are required to find what is the VP. So SVP is given this value, and they are in this formula. So RH is 40 degrees. So you put them into the equation, you end up with this question mark, this value, and this value. And you work out, once you compute all the value, you work out that the vapor pressure is 936. So just a very simple example of how the formula can be used to work out the vapor pressure. Okay, so this is the next thing lah. Once I finish this, then we'll be done lah for today. Okay, so this is a final thing. When it comes to humidity, we want to make use of different variable. So we want to make use of a chart. So this chart is called a psychometric chart. So this is a set or combination of different chart with different variable, which is correlated to humidity, to find out what is the relationship. So we have different variable in a single piece of chart, and then they can be used to correlate with each other. So in this chart, you have this dry bulb temperature. So this is just a thermometer glass tube thermometer, and then we have a wet bulb. So this is still the same glass tube thermometer, but they have the tip of the thermometer covered with cotton. So it's kept wet. So that's why it's called a wet bulb temperature. So remember, at different humidity level, there will be a different senses of temperature. So this is due to all the difference in heat transfer lah. So a dry bulb will might have a lower temperature as opposed to a wet bulb, because a wet bulb can transfer the temperature faster through the air or through this water that's contained in this cotton. So this way, there will be a difference in temperature although our air temperature we feel is the same, but when we are measuring it at a very accurate level, then with these two methods or difference of measuring, you can have two set of temperature lah, at the driest and at the wettest. So that's why we have this wet bulb and then we have this dry bulb. So next we have our dew point, and then we have our relative humidity, specific humidity, moisture content, and enthalpy. So these are the few terms that you can find in this psychometric chart. So we have this content, and then we have this chart. Okay, so I'm gonna open the chart here. Okay, you can find this chart in your document. Let's see here. So in your lecture slides, you can find it here lah. This is a psychometric chart. Okay, so if you look at it, there's actually a lot of information. So you can have your dry bulb temperature on the bottom. Then we have your relative humidity here. Then you have your humidity ratio on your right. Then you have your wet bulb temperature. You have your enthalpy, saturation temperature. So this is your dew point. And then if you look at it all the way to the right, you have your enthalpy. So this here are all different set of scale to showcase in a chart to work out our relationship between humidity and temperature. So in this chart, our air will always be at one point on this chart. So to make sense of how this chart works, so when we go up the scale, you know that the air is getting more and more moisture content. If you go lower, then you have less and less moisture content. So if you go towards the left or we go towards the right, there will be cooler air, hotter air. So how do we want to move or change or modify the condition of our air? So we can have these different terms or different steps to do so. So if you want to have a cooler and less humid air, so we want to move it towards this direction. So as they go towards this point, you want to cool down your air and you want to remove the content of your you want to remove the volume humidity content of your air. If you want to go back higher in this direction, then you want to heat the air and you want to add more water to the air. So it depends on which direction we want to condition the environment or the air in our building. Okay, so to make sense of how all this scale works, this is an example of how we want to read. So we can have a single point anywhere in a chart. To read the dry temperature, you want to draw a line down. For relative, the scale is here. And then for dew point, we want to draw a line to the left. Then the scale will be here. Wet bulb, the scale is this. And then if you go towards moisture, you want to draw the scale towards to the right. The scale will be here. And then you have your volume, which is here, the scale. You have different line here. And then, yeah. So it's a bit complicated if you look at it like this. So you have to try it out through example to showcase it to you on how to read the chart. So if you go zoom in, this will be a bit difficult lah, to showcase. So if you zoom in, you'll be able to see, you're able to make sense of what I just mentioned lah, just now. So here you have a wet bulb at 20 degrees. Okay, so let's see. Yeah, so this line here is a wet bulb. So the next, okay, so this line here is a wet bulb. So the next 30 degrees for the wet bulb is this line. So it's a bit hard to see lah. And then here you have your, here will be 24. Sorry, here will be 26, 27, 27, 28, and 29 here. So yeah, so the line all will be this line. So it will be this line here, it will be this line below here, and this line below here, and this line, and this line above, and then they go below. So make sure you don't confuse the stuff on this scale. Okay, so this one will be a bit difficult lah, if you don't practice, or it will take some time to understand, because there's a lot of line going all around. So to showcase to showcase the usage of this chart, you'll be better to go towards the example. So we can have example 10 here. We can have two air stream, one fresh and one recirculated air, with ratio of 1 to 3. So meaning we can have fresh air, 1 parts of fresh air, and 3 parts of recirculated. So it's actually there are 4 lah. So 1 to 3, 1 of fresh air, and then 3 parts of the recirculated air. So they are given dry 22 degrees, and then wet bulb 17 degrees, fresh air 30 degrees, and wet 22 degrees. So once we mix them together, what is the mixed air dry bulb, and then wet bulb temperature, and what is the RH? So we can use this chart to work out the answer. Let's zoom in a bit. So we can work out that at this value, the the recirculated air is 17 degrees. So this is the dry bulb on this line. Okay, let me change the grid. So this is a recirculated air at this line. So you dry up here, and you'll be able to read is 17 degrees in between here to here. So here will be 15. Here will be 20. So in between, it will be 17. And then you draw a line down. This is for your dry bulb. So here, there will also be a scale of, let's say, 20. So this is not clear lah. And then you have a 25 here. So there will be a scale here. You can draw down. And then this is your point A. This is for your recirculated air. And then this is for your fresh air. So you do the same for your fresh air. You draw the line to this direction for 25 degree, and then you draw it down for 30 degree. So this here is your dry bulb temperature. Then based on these two, because what this question is telling you is you are mixing this part, 1 part of fresh air and 3 part of recirculated air. So you draw a line in between, and you just do a very simple scale lah, of 1 to 3. So here it will be 1 to 3. You divide it, then you can work out what is the wet bulb temperature, which is this value, and dry bulb temperature, which is this value. And then based on this point, you'll be able to read the scale, which is here. Let me change to another color. So you'll be able to read the scale based on relative humidity from here, and you'll be able to work out what is the RH. So hopefully you guys understand. Okay, so if you read from the chart, you'll be able to get this value lah, 24, 19, and 63. So this is an example of being given these two value, the temperature, and then you just mark them on the chart, you divide them together, and you'll be able to get the mixed air, the end result of this mixed air. So what we are essentially doing is moving point to point lah, from this on this chart. So you'll be given 2 points, or maybe you'll be given 1 point for this example, this next example shown. So this example, final example, tells you that you're given air at 0 degrees Celsius at an 80% relative humidity, and we want to heat it up to 18 degrees Celsius. So what happens to the relative humidity when we heat this up? So what you're given is only 1 point for this example level. So for part A, what happens when we heat it up to this value? What happens to the RH? And then next, what is the relative humidity if we add more moisture? And then finally, what is the temperature at which this moistened air would first condense? So to work all this out, you're given a point, which is A here. So at A here, this is at 0 degrees. So 0 degrees is actually here. So you draw a line from bottom of the dry bulb to here, 0 degrees, you point it here. So how we get, so if you were to draw a point, you go from bottom to top, you will go all the way to the, you will go from bottom all the way to the top of the scale. So how do we determine the height of this point? So we determine it through the RH, which is 80 degrees. So from here, there will be a marking. You can draw a line all the way down and converge here. So this is 80%. Then the question part A mentions that what is the RH when we heat the air to 18 degrees. So remember, we got point A here. This is a point that we obtained from here and here. So once we heat this to 18 degree, we can draw a line. So we move this to the next point, which is B. So from there, because we just heat the air, the new point is at here. What happens to the RH? You have to refer to this line here, to this scale here. So this scale is between these two lines. So these two lines, let's say for example, this one here is 25 degrees Celsius, and then here is 20 degree Celsius. So you just try to assume is it between or more or less here and here? So for this example, the answer we are able to get that the new RH for this is 23 degree Celsius, 23% relative humidity. So this is for part A. So for part B, what happens if we add 0.005 kg of moisture added? So we're still same at here. When it comes to adding more moisture content to the air, which is here, original, we draw a line across. So we add 0.005, it will jump to the next height, which is C here. So still the same line, we draw it up. So part for question B, you have a new point which is part C. So for part C, the same thing, you work it out here. We work out about 65% of relative humidity and 60% relative humidity. So we look around these two scale, we work it out. At point C, you will get 62 degrees. Okay, and then finally, we have what is the temperature at which the moistened air would first condense. So the final point that we have, we ended up as point C because we add this extra moisture content into the air from also heating this up. So finally, to get the dew point, you want to draw a line across our point C. So this is our point C. We draw a line this direction towards this scale. Then we can read that this scale here is the extreme value lah, of the dew point. So once we draw a line in this direction all the way to the left, this is the value of our dew point temperature. So hopefully you guys get lah on what all this is about. So the previous example shows you the way on how to read this chart, and then this chart here, this picture here, shows you the direction of how we should draw based on this point. So if you want to find out what is the dew point, we draw it this direction, we get our dew point temperature all the way lah. They are on this scale. This is called a saturation line. Okay. So depending on where we are at, we can have higher or lower, and then at this point, based on this scale, we'll be able to find out what is our RH. We go to the right, then we have our moisture content. We go down, our point of height here, we can find what is our dry bulb temperature. Then our wet bulb is on this scale on this scale of line. So there will be a lot of line here. Okay, so this showcase an example of how we can make use or how we can read from this chart. So this one, so this one you have to practice on it to know how to work this all out. So it's a bit difficult for me to just show it to you guys like that. Okay, and then with that, I'm finished with this topic So if you have any question, feel free to ask. So we got about 5 minutes left.